Yeah. Start from there. Right? Start with that first line. Get it all the way out. Don't even pause like that. Don't worry. Okay. Anyone able to get it out? A plus B all squared greater than or equal to 4AB. Okay, fair enough. What do you have?
Yeah, I got it out.
Oh, how did you do it?
So I did since a squared plus b squared is greater than 2ab, which we proved in the thing before.
Cool.
If you add another 2ab to that, you get ab whole squared,
I like
and
it.
which means
All you've got to do is just add 2AB here, and that becomes a perfect square, but as long as you're adding it to both sides, you get it becoming 4AB. See how it wasn't hard? I wanted you guys to realize you can, again, get something. I've got this, I need this. I've got this, I need this. What are you going to do about it? You're going to try to realize, firstly, what I would realize is, hang on, that's not a perfect square. That's a perfect square. Let me expand this. I've got an extra 2AB. Oh yeah, if I add it to both sides, it works out. Way, I think you should do it. There it is. I just added 4AB on both sides because I can. It doesn't even matter. Right, you can add 4AB to both sides, can't we? Yeah, makes sense. Done. All good? Sweet. Question 3. Try to see if you guys can prove this result now. In any way you want. Any way you remember. That's right. Yeah. Start with A minus B, all squared. Okay. Immense. Oh my God. If you know what to do. You think you remember it? Square root starts. Try to remember how to get it today. Okay. Who got it out? Anyone got it out? Number 3?
I think
yeah,
I got
I
it.
got it out.
Yeah, what'd you do?
So I did a root a minus root b whole squared.
Oh, you
So
actually
then
saw
I
that?
got
You actually realized to do root A minus root B?
yeah.
That's fine. If you know what to do with that, you understand it that way, good on you. Right? If you didn't, it's okay. Did anyone do it differently?
I did it some other
Yep.
way.
Yes, tell us.
I squared both sides, so you got a plus b squared over 4 is greater than or equal to ab. Then I minus 2ab
Yep.
from the right hand side
Yes.
and the left hand side. And then I
Yes.
got a squared plus b squared over 2 is greater than or equal to ab, but then I
Yes.
stopped there.
And then you have got something like this. And then it's great. You know this result. The problem is you use the result to get something else that we know. And if you remember, you're not allowed to do that.
Okay.
So it's fine. What you can do now, you just rewrite everything backwards. Remember me saying that? So,
Uh,
so this becomes your first line, this becomes your second line, this becomes your third line. Whatever you've done becomes your fourth, and then your fifth, and so on. So when we read it, it looks like you pretty much proved this result.
wait, so I don't get that.
Going backwards,
Can you say that again, please?
hold on. What I'm saying, when you've used this, and you're saying, hey, use this result and then square it and blah, 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 and you get to a result that we know. Let's just say you did a bit of math and you got to this result. You can't say, since I know that a minus b all squared is greater than or equal to 0, therefore it's all true. You can't do that for these questions. We will do that for the part 1 of proofs which I've missed. But you can't do that for these styles of questions. They're not allowed. What you can do, if you did do that, this becomes your step 1. This becomes your step 2. This becomes your step 3. Do you understand that, Anouk?
Yeah.
So you can't use the result to prove something else and say, because this is true, therefore the result is true. That's not allowed. But you can do it, just rewrite everything backwards. So to us, it doesn't look like you've used the result. When we read it, it looks like you actually proved this. This is what I would have said to you guys. I said, start off with this. I'm trying to tell you guys, more likely than not, it's this. Oops. We end up with this. We end up with this. Look how close you are. Divide by 2. There. You're bloody close. You can't square root because you square root whole sides. So it'll look like this. So be careful with that. What do we usually do at this stage? Does anyone remember? Let. Any idea? Yeah, no, nothing. Let a squared equal to x, b squared equal to y. What do you end up with here? A squared becomes, b squared becomes, onto, it's greater than or equal to, what does a become? Root x, and what does b become? Root y. And you just prove that result. Does that make sense? Yeah? Yes. So if I said a squared is x and b squared is y, a squared is x. Now hold on. A squared is x. B squared is y. I'm substituting. Over 2 is greater than or equal to, what's a equal to? A is root x. B is root y, so root xy. That's what I would do. If you don't know what to do, that's probably the best method. If you get it and you understand the whole square rooting business here that Greg just said, great on you, good on you, whatever. Okay, it doesn't really make a difference. Either method, I think this method's really strong. Yeah, of course, it's just letters, right? Right? Isn't it? Just letters. I could have said L plus M over 2 is greater than or equal to square root of Ln. Doesn't matter, it's just letters. Is it specific for A and B? That's the idea. No way, it's just any letter, any number. As long as you divide it by 2, it's going to be greater than or equal to square root of AB. If you wanted to, you could always change it back, but no, full marks. Okay. Now, the next one, question 4. We want to prove a squared plus b squared plus c squared is greater than or equal to ab plus bc plus ac. A squared plus b squared plus c squared is greater than or equal to ab plus bc plus ac. Anyone remember what you're meant to do with there's 3 of them and they're squared?
You know that a squared plus b squared is greater or
Yes.
equal to 2ab, and then you do the same with b squared plus c squared, which is, yeah, and then a squared plus c squared.
That's it for now. Let's go. You see, pretty much Ben just said, pretty much start with what we've always started with, and then write your results for A and C and B and C, and then add, and hopefully you end up with this result. So try that out. Nope. You start with A minus B all squared is greater than or equal to 0. That's your starting point. Correct. Yeah. Constant minus constant. The one on top is negative 14. Take those 5. You've already lost 14. You lose another 5. You've lost 9. So it's going to Negatives are one next to each other. One next to, are they one next to each other? Are these two right next to each other? Yes, that's the point. Minus 7 plus 3 is minus, so minus 7 plus 4 is minus 7. You lost 7. You gained 4. You still lost 4. Every time on the top, minus 2. Double check it after you're done. There's no point getting it. I think you're going to be wrong. Brilliant. Beautiful. Then you do the same result for, you've got A's and B's. You have to have the same results for A and C and B and C. So you're going to say, no, this result, you write it for A and C and B and C. So A squared plus C squared is greater than 2AC. Remember, just letters. Okay, let's have a look at this one. So, Mike, Ben, oh sorry, yeah Ben, it was Ben, wasn't it? Like Ben had said, A squared plus B squared plus C squared. When you get a question, there's 3 terms, they're squared. You start off with your first one. There it is, A squared plus B squared is greater than 2AB. Then you rewrite the same results for, alpha, beta, alpha, gamma, beta, gamma. You can think of it like that. But you write the results for the other ones. There it is, and then just add them up. So A squared plus A squared, 2A squared. B squared plus B squared, 2B squared. C squared, 2. On the right hand side, you're going to get 2. Divide everything by 2. And by a stroke of luck, it should work out. Yeah? Done. Any questions from anyone? Okay. Let's go to the next one. D. Deduce that if A, wait, nope, something's wrong. Hold on. Question 4. I need question 5. Looks like I scanned these backwards. I'll find this. Yes. Thank you. See? You need to have logic. I don't have any right now. 5 should be up here, right there. Thank you. 5, A to the 4. Prove A4 plus B4 plus C4 is greater than A squared B squared plus A squared C squared plus B squared C squared. Alright, let's go try that. I'll give you a clue. Start the same way you would have with A squared B squared C squared, the one that we just did. Start the same way. Get it out? Nah, you're lying. Alright, let's see. See how good it feels? I missed that smile. Alright, let's go. So, again, because I know what I'm doing, I can do things a little bit differently. But I hope it shows you, you guys probably didn't do it like this, but you can do it with a squared minus b squared, right? What's holding you back? Why not? Because when you square it, I missed a square there, if you square it, it becomes a4 plus b4 is greater than 2a squared b squared. If you didn't get that result, you guys obviously by now know this result. You could again say replace or let a squared equal to x power 4, b squared equal to y to the power 4. True? Which means you get x4 plus y to the power 4 is greater or equal to 2a. A means square root of x power 4, which is x squared, y squared. And then, which is this exact same result. And then you'll write the same thing for x and y and z. Alright, I'll look at it in a second, and then you're just going to add it up, and hopefully you end up with the same result. Let's see your one. Yes, yes. No. It looks like it should be allowed, shouldn't it? Let me write that to everyone. It looks like it should be. Look, you're doing what I'm doing here. The problem is, you're saying I'm going to square everything, but that's technically not allowed. That's all. Just fix up that one. So let me show you. Mariette's got this, and we just want to make it clear. Is greater or equal to, I think, AB plus AC plus BC from before. And then what she had written is this. What's the only problem with this? Because it looks freaking close. So what's the problem with it? Can anyone tell us the problem? Greg, what's the problem with her doing this?
Like, you can't
Oh,
really
there's no problem.
do that.
Sorry?
Yeah.
You have to square the whole thing. You can't.
Yeah,
square
yeah, you have to do it the whole thing if you're doing it like that.
Yeah, it has to. Whenever you're trying to do squaring or anything, you're doing it to the whole thing, so it looks like that. Square it, okay, square it looks like that. Do you get what I'm saying? Yeah. You can't do it to individual terms. If you could, then all of a sudden, when you have this result, let's just say equals 5, you would say, okay, square it like this. Is that true? No. You can't do individual terms. It's to the whole side. That's all. So it looks, look, I can see where you came from, like, because it looks so allowed, but it's not. It's not allowed. Because of binomial expansions and everything like that, right? So the way you should have been is what you had, exactly as you had it in black. You would have just said let a squared equal to, let's say, x4, b squared equal to y4, and then let's say c squared equal to z to the power 4. And then you would have ended up with the same result you actually got. Does that make sense? So just instead of squaring it like that, think of replacing or letting. Okay, anybody else wants me to double check anything that they've got? Okay. Let's try another one. Try to prove this result now. A plus b plus c all squared is greater than or equal to 3ab plus ac plus bc. Clue for this one. I don't know if I've got one from the top of my head. Clue. Clue. Oh, okay. I think so. Yeah, right? Should be, if I'm not wrong from the top of my head. Okay, I'm going to give you guys a clue. I'll say expand this. So we're going to use it for a second. expand to realize what this is, right? Just expand only this, and then think, and then I'm just going to say expand and think. That's it. It's something you've done. You'll realize it, hopefully, when you've expanded it. And see if you can actually execute it properly. But expand that, that might help. Remember, you can't use the result. You're just going to expand it first. Only that left bit, not the right, just the left. Take your time when you're expanding, don't forget 3 terms. Right? A plus B plus C. Maybe write it as 2 brackets if you want to. Question? Negative and positive. What is a negative and a positive? Okay, so what's minus 9? 9 is another 7. They're not next to each other. This is plus. No. Minus 9, minus 73. Well, you don't even put, yeah. No, not really. So when it's like that, you lost 9, you put it on the 73. You technically can add 53. Because you lost, I thought you lost 9, you lose by 1. Because you lost 10. Well, here you go, 9 plus 1 is 10, and I've lost minus 10. So you're not actually adding, you're adding to easier to your head. Literally, it's easy to add. Negative 9 and minus 1 is written plus. It's minus 10. In your head, you can think that 9 plus 1 is 10 and minus 10. So here, minus 9 is minus 73. And then 9 plus 73, 82, minus 82. You get the idea? I know it's tricky. But should be here. Alright, I know you will. Okay, let's see, what do you have? I think that's good, isn't it? Right. All right, I think it looks right to me. All right, so look what I did, left-hand side. A squared plus AB plus AC plus AB plus B squared plus BC, blah, 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 blah. Okay, we get it. And eventually you end up with this. A squared plus B squared plus C squared plus 2AB plus 2AC plus 2BC. So you either expand it using 2 brackets or you know how to expand it properly. It looks like Mediator knows how to expand it properly, so that's great. Then, does this ring a bell? Yeah, does it ring a bell to you? Look at question 4 or something. Or 3, whichever one it was. Wasn't it? Weren't you required to prove literally something that had this? A squared plus B squared plus C squared? Question 4. So it should ring a bell. That's very similar to question 4. In question 4 we knew what? We knew that A squared plus B squared plus C squared is bigger than or equal to AB plus BC plus AC. Does that make sense? And then obviously what am I going to replace this thing for now? AB plus BC plus AC, and then what happens to this? You're going to get 3 lots of them. So greater than or equal to AB plus BC plus AC, and then you get, which equals to 3 times each. So essentially this is just the same as question 4 with an extra this added to both sides. Just like we did this. Let me just show you guys. Just like here, this one here, Greg was like, I just add 2AB to both sides. So this question here is exactly the same, just adding an extra AB plus BC plus AC to both sides of whatever the result was that we had in question 4. So go ahead and copy that down. Again, anyone actually get it out all the way or realize that there was a there was a link to question 4? No, not yet. That's fine. Make sense?
Sam, I think I got it.
You got it?
Yeah, on the left-hand side, you got a squared minus b squared minus 2ab. Actually, never mind. Hold on.
How come minus?
Should it be a plus?
Yeah, it should be pluses.
Yeah, I think I made a silly mistake. Give me a second.
Wait, are you asking us the answer, Sam? Like how you proved it?
No, there's no answer. That's it.
Oh, yeah. Like, are you asking how we proved it?
No, yeah, like, did you guys think of it like this? Did you see
Yeah,
that?
yeah. I just added when we proved a squared plus b squared plus c squared equals to is greater than or equal to ab plus bc plus
Yeah,
ac.
sure.
What I did was,
Added 2 lots extra.
yeah, I added, yeah.
That's fine. If you can realize that, that's great. A lot of students don't know the expansion of a plus b plus c all squared. They don't know that it becomes 2 times. So I just tell them expand it, and then from there you realize, oh, I'm pretty close. If you just knew the relationship between a squared, b squared, c squared. Okay, all good. All right, number 7. Number 7 should be up here. All right, try to see if we can prove this result. X on Y. I would really like it if you all can get this result out. Nothing hard about this one. Just think creatively. Again, we've done it before. But think creatively. Start from your first line forward. What's your first line? A minus B or square. Start from that. So same. It's a negative and a positive, it's a negative. The negative and negative is the same. Positive and positive is positive. Pretty much they're the same. They're not the same. Now these ones don't matter in this picture. You would multiply them, they are going to switch up. This is confusing. So this is a negative, straight away. But with that, adding and subtracting, those ones there, they have to be able to switch up.
So this one would be 4
4 times 60. Oh, haven't seen that done before. Yeah, of course, that one's a left. See? Creativity. Why not? Because if I had shown you my way, you would have said, okay, that's the only way. But it isn't. There's literally, now there's probably like 5 ways that I now know. That's cool. Never seen anyone do it like that. I like it. I'll start showing that as well. Okay, so again, you can see the 2 gives it away. I mean, it really has to give it away to you guys. So you start off from this, x minus y squared, greater or equal to 0, x squared minus y squared, whoops, plus y squared is greater or equal to 2xy. I think we're used to that by now. What Maria just did is actually she divided everything by xy. So she's like, yep, divide xy, got rid of it. Divide each term by xy. She at least knew that, which is really important because if you didn't, it wouldn't have worked out. X, and that cancels out, that gives you x on y squared, and the y cancels out, that gives you y on x, greater than 2. Perfectly allowed, 4 marks. The next solution would have been if you had x squared back to here. And what if I want to say let? Can someone tell me what my let would be? Let on b. You actually want to get this, a on b. And then y squared equal to b on a. And let's see what happens. This becomes a on b, voila, plus b on a, voila, greater or equal to 2x. So root a, root b. root A on root B times root B root A. This cancels out, this cancels out. You get the same result that you did. Last one. Anyone know a third way now? Maybe Greg, something that you would have done with the third question that we did before. Any ideas, Greg? Surds. The way you did it with your surds.
I did it. What I did was I start from where Marriott ended, so I just work my way back up. But I didn't do it the third way for this one.
Sure, I got it. But I'm saying if I had to, a third way. It
A
would be
third
what?
way, maybe root x y, like root x on y. Yeah, that one. Yeah, can't speak. My bad.
Root y on root x. That's all. Why? Because what happens when you square this? Gives you x on y. What happens when you square this? Gives you plus y on x. Then 2 times the inside. These two cancel out, these two cancel out. Just go and make it a 0, and you can get the same result that you want to. I'm trying to show you guys, like, 3 different ways gives you the same answer. I think the easiest one seems to be this one right now. I like it. But again, it's what you would do. If you get used to this and you know that, great. If you don't, you get used to the leading, great. If you really understand it in a very advanced way, you can do the third. Okay.
Sam?
Yes.
I did a different way, but I
Oh.
kind of got, yeah.
Let's see. Let's hear it out, because
I'm not sure if it's right though, so
that's why I want to hear it. Go.
I did let x equal a, let y equals b. Then I simplified that, and I got a squared plus b.
Simplified what? Simplified the x squared plus y squared?
Yeah, and I got a squared plus b squared greater than equal to 2ab.
Yep. No, you mean a plus b.
Yeah,
Wait, a squared plus b. Did you just let x equal to a?
yeah.
Well, you just replaced the letters. That doesn't do nothing. But yeah,
Didn't we have a result like that earlier?
sorry? No. I let it become like a squared or b squared or something. But if you're just going to change the letters, that doesn't really make a difference.
Okay.
Do you get what I'm saying?
Yeah.
Like this line that you've written up here compared to the second line up here, they're the same, aren't they?
Yeah, they are.
Yeah. I think you meant x squared equal to a, y squared equal to b. Then you would have said a plus b is 2 root ab. Like
Oh,
that.
okay. Yeah.
Because x is root a, y is root b. Fair enough. Then from there, I wouldn't. Yeah, you're going to get stuck, because then you're going to have a on root ab. Let's say if we use Marriott's solution, which works, actually, still works. You know, look, a on root a cancels out. You've got root a there, and you still got your root b on the bottom. B and root b, it cancels out. You're going to have root b on the top and then root a on the bottom, because it's bigger, right? I don't know if you guys can see this. That's a power of a half. So this will cancel out. You're left with half on the top. So it works, is what I'm trying to say. Not like why.
Okay. I didn't see that other way.
Yeah, I know. All good. All good. All right, the reason why I'm giving you guys these is so it can show you like the ones I really need you guys to know. If you know these, you can safely say 8 out of 10. I'm not going to tell you 9, because it's not. 8 out of 10 questions are done, which is still pretty high. All right, number 8. X cubed plus y cubed plus z cubed. That's going to be rather interesting. I'll give you a clue. You have to start at this point, but you can't just start at this point. So you guys are going to prove this result first. So prove the result for this one again. How do we prove that one? Right, x squared plus y squared greater than equal to 2xy. Then you're adding all the 3 terms, whatever. Yeah, so start from, literally you're going to start from here first. Eventually get it down to this result that you had here. And then let's just say think creatively. That's all I can say at this point. So start from your original, as always, get it to this point, and then if once you're at this stage of whatever you've got, try to see if you can really finish it off. It won't be a let. You're not going to just say let this, because obviously it's a cubic. And then I'm about to teach you something really important with cubics now. Okay, so if I'm not wrong, and you guys can see what I keep doing, I keep starting from the top. But you can't just start from a result that we know. You've got to assume if this was a standalone question, your examiners don't know how you got this result. You start from the top. And you go, and you go, and you go, and you go. These are Z's. You go, continue. Okay. Where's my number 8? Don't have it here. Maybe now it's on the other page. Nope. Alright, if I'm missing it, I'll just do it myself. Oh, there it is. Yep. Alright, here we go. So, continue. There it is. X squared plus y squared. That's the result we know. Are we comfortable with that line? The only way you're going to get odd powers in is by multiplying both sides by x plus y plus z. So then you end up with this plus an extra bit of this. But that's okay, because when you expand your right-hand side, all of these bits will cancel out. So please, you guys, start from your line, multiply both sides by x plus y plus z, and get me my final answer that I want, which is this one right here. Just a bit of expanding, there's really nothing to it. If you feel more comfortable with A, B's, and C's, use A, B's, and C's. And that is where we're going to leave it for today. So finish it off. If you feel comfortable with that, leave it there for today. But write it all down first. Not the way I've written it, because I'm obviously talking to you guys and like, we need this, but you need to write all that. Just write this first, then expand. Then you do the expansions yourself and get this result out. Get it out. It has to work. Yeah, two negatives next to each other. So that's technical. But if I said what's negative 65, take away 37, plus 37, negative. Alright, are you okay? So look. So you expanded this left side, now you're going to expand the right side. When you expand your right side, every one of these terms need to cancel out. So just focus on your right. Just the right hand side equals, and just expand the right hand side. Any questions, you guys?